My dear students, today we are going to discuss about 7 segment display decoders. These 7 segment display decoders are of two varieties. One is common cathode type, common cathode type. The other one is common anode type. What is this common cathode and common anode? If I take a diode, what is that diode that we are dealing now? Here is light emitting diode. What is the difference between diode and light emitting diode? When we turn it on, we will get a light. Okay. So this is cathode and this is anode. Okay, positive terminal, negative terminal, right? So common anode, common cathode. What exactly, if you see here is a common point. So that common point, what exactly that we are doing? A is connected to common point. A is an LED, light emitting diode. B is an light emitting diode. Where they are sitting in 7 segment displays like this. 7 segment display looks like this. There are 7 segments. Okay, in each segment there will be a diode. So at this segment there is a diode, in this segment there is a diode, in this segment there is a diode, in this segment there is a diode. So 4 plus 3, 77 diodes. How they are represented? They are represented as A, B, C, D, E, F, G. This is A, B, C, D, E, F, G. There will be a decimal point which will be represented as H. Okay. To represent a number is not required, but to represent a floating point number we may require decimal points. So for this there may be a diode. Okay. So here I have shown DP, decimal point, right? So generally the 7 segment display is consisting of 7 LEDs. Those LEDs may be connected as common cathode or common anode. What is this common cathode? Is for all these LEDs or the light emitting diodes that we are using 7, where what we can do is all anodes we can connect it to ground. Anodes or cathodes. So if I take anode, this I can connect it to, for all of them I can connect it to plus 5 volts. So for this to glow, this to LED to glow, this has to be connected to ground. Connected to ground means you have to apply 0. Or if I take a diode where its cathode is connected to ground, to make this to emit the light to turn it on, I need to give plus 5 volts. That means logic 1. So if all are connected means I take A, I take B, I take C, D, E, F, G. So what I try to do is all cathodes I will connect it to ground. So I will take this point, I connect it to ground. Internally, that is not being shown. For everything to be on, if I give A1, this will light, it will emit light. If I connect 1 to B, it will emit light. I will connect C to 1, here I give 1, logic 1, it will emit light. So if I give 1 here, it will emit light. Okay. So here this is ground. So that is connected to ground. That is which is exactly I have shown here. Ground is connected to ground. Okay. So what is going to happen is when I give 1 to this will glow. This will emit light. This will emit light if I connect 1 to here. Okay. Yes or no? Right. So the one which is connected to G, if I connect it to 0, it will not emit light. So this is glowing. Everything is glowing except G. This is glowing. 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 But this is not glowing. Means what we are doing? We are displaying 0. Similarly, if you want to display 1, I have to glow this one, I have to glow this one. Similarly, I want to glow 2. So 2, 3, 4. Likewise, we can display various digits either by using common cathode or common anode. In common anode, if I want to glow it, for this LED to glow, I need to give 0, because this is what exactly the common point which is being connected to VCC. So we will give 1. We will give 1 means common anode. All anodes are at 1. All anodes are at 1. That is plus 5. Ones are logic 1. Anode is all anodes. Anodes of how many? 7 diodes. When all anodes are at 1, if I give 0, this is at 1. If I give 0, this diode will be on. So we need to give 0 to turn on the diode. In common anode, in common cathode, we need to give 1. So common cathode is active high logic. Active high logic. Whereas common anode is active low logic. Active low logic. Why? When I give 0, then only LED will turn on. For what sake this is? If I give 0, I should have to display 0. If I give 1, I have to display 1. That means whatever the number that I am sending to this output device, this LED used as an output device. If we want to display some value, not a number, we will be using LEDs. 7 segment display devices. Okay, those are made up of light emitting diodes. LED means light emitting diodes. Each segment is a light emitting diode. Light emitting diode. LED. Okay. So how many inputs it has? 7 inputs it has. But what is the value that exactly that I would like to convey? 0 to 9, which I would like to display. What is this 0 to 9 binary coded decimal? How do you represent this with 0 to 9? I can by using by 4 zeros to 1001. 001, 010, okay? 0000 will give you 0. 0001, 1. 00102, 00113, 00010, okay? 4, 01015, 01106, 01117. So I am giving 4-digit number. This 4-digit number has to be converted into 7-digit number, so that I can give it to the 7 segment display, so that I can display the value. Okay. So for that we need to design a display decoder. This is what exactly the case. So I would like to design this hardware. What exactly it is it will take 4-bit BCD number. That means it will take 0 to 9. It will give A, B, C, D, E, F, G, H such that if I give 0, it will display 0. If I give 1, it will display 1. If I give 2, it is display 2. Okay. If I give 3, it will display 3. If I give 4, it will display 4. If I give 5, it will display 5. If I give 6, it will display 6. For that, what we need? We have a 4-bit input, but we should get an output which is supposed to glow the LED such that these numbers will be displayed. To display 0, when input is 0, 0, 0, what should be the output? Output should be, if it is active high logic, I need to give A1, B1, C1, D1, E1, F1, G0, so that I will get 0. This is glowing means A glowing, B glowing, C glowing, D glowing, E glowing, F glowing. F not glowing. The F is there but not glowing. Not glowing means G is there. G is there but G is not glowing. Not glowing means G should be 0. G should be 0 means this is not going to glow. When this is not going to glow, I can see only this part, which is 0. So likewise I need to get. So I know the input is BCD and output is Output is such that it has to drive the 7 segments of LED display. 7 segment LED display I need to drive. So I need a particular hardware here such that if I give 4 inputs, I'll get 7 outputs. These 7 outputs are such that it will glow particular value on the 7 segment display. So the circuit which is capable of doing that is called BCD to 7 segment display decoder. Why it is called a decoder? It will convert the numbers, BCD numbers, into another form where if that form is given as input to the 7 segment display, that number will get displayed. Okay, that is the overall idea. For that, you may be using active high logic or active low logic. If you are using active high logic, okay, it is something like this. Say A1, right mark means 1, right means on. So A on, B on, C on, D on, E on, F on, but G is not on, 0. B on, C on, 1. Okay. Then A on, B on, D on, E on, and G on. 2, 3, 4, 5, 6, 7. This is active high logic. What is the active high logic? It is a common cathode method. What is common cathode? All the LEDs are all LEDs. 7 LEDs. All 7 LEDs. Okay, what are these? A, B, C, D, E, F, dash, 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 last till up to last. For this, what we are doing? All cathodes are connected common. Give it to the ground. If I give one here, this will glow. If I give one here, this will glow. If I give one here, this will glow. So we are glowing these LEDs based on our requirement, whether we are displaying 0 or displaying 1 or displaying 2. Okay, based on that, displaying 3 or displaying 4. Which one to glow, which one not to go. Based on that, what exactly we are getting, we are supposed to apply is A, B, C, D, E, F, G values. Okay, based on that, I can go up to 9, then you can have A, B, C, D, E, F. Okay, by using 7 segment display. Right? So how to design that decoder? How to design this decoder is known as BCD to 7 segment display decoder design. So 7 segment display decoder design, if at all you want to do it, you have to develop a truth table. What is the truth table? What is the input that you are applying? What is the output that I want? So these are the inputs. These are the inputs. And this is what exactly output I need to get. This output I am giving it to BCD to 7 segment display. So 7 segment display. For this, I am giving it to 7 segment display. 7 segment display. 7 segment display. I am giving this to 7 segment display, where A, B, C, D, E, F, G. So here is A, B, C, D, F. What are the inputs? BCD input. Okay. So now BCD input is only from 0 to 9. What about the rest? Rest are don't cares. Okay. So input output relation we can see. So we need to get how many k-maps required. So A, small a is function of A, B, C, D. Likewise, everything is function of A, B, C, D. B is also same function of capital A, capital B, capital C. Likewise, G is also function of A, B, C, D. So what I do? I'll get expression for A, I'll get expression for B, I will get expression for G. Okay, for example, if I want expression for A, okay, what is A? A is sigma m. It is 1 for 0. For 2 it is 1. For 3 it is 1. For 5 it is 1. For 6, 7 it is 1. Then it is 1 for 6. For 3 it is 1. For 5 it is 1, for 6 it is 1, for 7 it is 1, for 8 it is 1, for 9 it is 1. For 8 it is 1, for 9 it is 1. Plus don't care terms. What are the don't cares? For everything which is greater than 9, 10, 11, 12, 13, 14, 15, it is don't cares. So use this in K-map. Take a K-map for A, get the expression for A. Similarly, get expression for B, get expression for C, get expression for D, get expression for E, get expression for F, get expression for G. From those expressions, I can realize the circuit. That circuit is nothing but BCD to 7 segment display decoder under common cathode method. Same thing we can do it. You take the K-map and you are supposed to make K-map simplifications up for A, B, C, D, E, F, G. Okay. Similarly, common anode, ABCD is given to you. ABCDEFGH, what we are getting over here is active low logic. So to glow A, I should give 0. B, C, D, E, F, G. Give 0 here, give 0 here, give 0 here, 0 here, 0 here, 0 here. 1 here. So that it will not glow. Everything is glowing. This is 0. That is what exactly the constant. Okay. So for this, what we need to do? For this, what we need to do is, so you try to write the expression for A, B, C, D, E, F, G. Then use K-map, find the solutions, and from that solution realize the circuit. That itself is BCD to 7 segment display decoder for common anode method. Is that fine? Okay.